Hey everyone, in this video and the following videos, we're going to be looking at how we solve system of equations. So what exactly does this mean? You might be wondering. A system of equations, and what is a system? What does it mean to solve it? To solve a system of equations, first of all, we have to be given two equations. We look for the point, so the point xy that satisfies, keyword satisfies, both equations. Okay, so this word satisfies, what does that mean to satisfy an equation? So I can tell you, just an example here, the point -2, 3, it satisfies the following equation. So the equation is 3x plus y equals -3. So I tell you that this point satisfies this equation, and what that means is when I place x and y into this equation, this left side will equal the right side. So when I place -2 in, so 3, place -2 in for x, and place 3 in for y. Okay, so -6 plus 3. -6 plus 3 is -3. And we see that the two sides equal each other. So when a point satisfies an equation, that will happen. So if I were to plug in, 0, 3, and place those values in, it would not satisfy it because what I get on the left side would not equal what's on the right side. Okay, so to satisfy an equation just means that when placed in, both sides of the equation are the same, are equal to each other. So to solve a system, we look for one point that satisfies two equations, and you'll have these two equations given to you. And there are different methods of solving these problems. So to begin with, let's look at, there are three different possibilities. So these here, there are three possible situations. There are three possible situations when solving a system of equations. I did not even think about this. This word system is referring to a group of equations. So when I solve a system of equations, I'm finding a point that fits a group of equations. And at the beginning here, we're just dealing with two equations again. So our three possibilities are standard form, where both of them are in standard form. So recall standard form is when both our x and y are on the same side, whether left or right, they're on the same side. So then the other situation is when one equation's in standard form, and the other is either y equals or x equals. So that's another situation that will require a completely different process to solve than this first situation. And then we have both, when both equations are in y equals form. So I have examples here. So as we're doing these problems, I encourage you to write these down, to have paper, whether it be graph paper or just your notebook paper, to write these examples down, to pause the video at any point, rewind at any point you need to, but really utilize this video to understand how we solve systems with the various situations, okay? In this video, in this lesson, we're going to be looking at how we solve systems of equations when both equations are in standard forms. We're focusing on this situation here. So if you have yet to look at the other two situations, I have the link here on the screen. I encourage you to watch these lessons first before looking at standard form, because it should just progress to this last one. So when the equations are in standard form, we have this method titled the elimination method. So this is the method where both equations are in standard forms, just like we see here. So this elimination method, it's in the name elimination. We are looking for, we look to see if a pair of x's or y's cancel. Okay? And what it means when I say cancel, that they'll combine to 0. And how they combine to 0, one's going to be positive, one's going to be negative. Like positive 4, negative 4, oh, look at that. So we see this here. So one way of using the elimination method, if you've seen this before, most likely you've just seen people draw a line and then like kind of crossing out stuff. But one way of doing this is actually combining this first group, say 3x plus 4y, and combining it with the second group, 6x minus 4y, and then combining the right sides, 10 plus 8. So now, doing this, we can combine like terms. So I see a 9 and a 6, sorry, I see a 3 and a 6, which combines 9x, and we see a positive 4 and a negative 4, and they cancel. So the positive 4 to the negative 4, that's what it means when they cancel. They eliminate each other. So then 10 plus 8 is 18. So now we know from here we divide by 9, and 18 divided by 9, we get x to be 2. But as the other methods, once we get our first value, we have to place it back in to the other value. And I want to say here, with the substitution method, we placed this into what was called the initial equation. So to find the other value, we substitute this value into either equation. My red pen's dying on me. So I can place 2 into either equation. As long as I do my computations correctly, I should be okay. So I'm going to just choose the first one. So x is 2, so 3x plus 4y, I'm going to use this one. I'm placing x into here, so that would become 3 times 2 plus 4y equals 10. 3 times 2 is 6. Okay, so we know from solving, subtracting 6 to both sides, that would give us 4y, so 10 minus 6 is 4, divide by 4, and we get 1. So we've placed it into the first equation and we got 1. If we would have placed it into the second equation, we would still get 1 actually. So our solution is 2, 1. That's the solution to our system. So with the elimination method, sometimes the equations will right away have variables that cancel, that eliminate. So let's just look at another situation like this. So let's say we have 2x plus y equals negative 1 and 3x minus y equals negative 9. Then you could put this group in parentheses, adding this group in parentheses, and then do negative 1 plus negative 9. You could do that like we saw in the previous example, or as most of you have already seen it this way, we should leave it what we're called stacked. So we notice here, that I have a positive y and a negative y, or a positive 1 and a negative 1. They will cancel to here the y's are going to cancel or eliminate. 2 plus 3, when you combine those, you don't get 0. That's why I'm saying not the x's, but the y's. So you cross these out. Now with the stacked method, I combine them. So positive 2, positive 3 is positive 5. Negative 1, negative 9 is negative 10. So we divide by 5. Dividing by 5, you get negative 2. Now we choose either equation to place this back into. Let's use the first equation, because why not? Okay, so 2 going into x is 2 times negative 2, okay, which is negative 4 plus y. So having a negative 4, I have to add the 4 to this, so negative 1 plus 4 gives us positive 3, which is gives us our solution. Negative 2, positive 3 is the solution. If you wanted to check it, you could place negative 2 into x, positive 3 into y. So that would be negative 4 plus 3. Yep, negative 1, it would work there. And if you put it into the second equation, it would work as well. But what if nothing originally cancels? What if we have a situation where nothing cancels with what we have? So let's look at a situation like that. So say this problem. So we have 2x plus 2y equals 4, negative x plus 2y equals 4. So notice nothing cancels. One great thing about math is we can do certain things to make a problem work for us. So what we can do here is we can multiply. An equation by any value we want, positive or negative, in order for x's or y's to cancel. So if I could see that I can multiply by something to make it cancel, I can do that. So I look at this. Okay, right now I have positive 2 and negative 1. So I could multiply this by 2, and then they would cancel. I have 2 and 2. I could multiply one of these by negative 1. I would have positive 2, negative 2, and they would cancel. So I could do either of those. I can multiply by 2, x's would cancel. I could multiply by negative 1, y's would cancel. Let's just go ahead, let's multiply by 2. Okay, because the previous examples we canceled the x, or we canceled the y's. Let's see what happens when we cancel the x's. So let's multiply by 2. So let's write this down. So 2x plus 2y equals 4. And I'm going to multiply my second equation by positive 2. And since I'm modifying one number, I have to modify all of them, hence the parentheses. So we do this, and we get, so our first equation stays the same, 2x plus 2y equals 4. My second equation becomes negative 2x, positive 4y, and 2 times 4 is 8, positive 8. So all of that, so our x's would eliminate. Now we combine. Positive 2, positive 4 is 6, 4 and 8 is 12. So we divide by 6 and we get 2. Now with regard to placing this back in to get our x value, I could place it into our original 2, or I could place it into the modified equation. So I have 3 options here. So it doesn't really matter here. I'm going to place it into the first one. So 2x plus 2y equals 4. We have y to be 2, so 2x plus 2 times 2 equals 4. That's 2x plus 4. I'm going to take away 4 from both sides, which gives us 0. Then we divide by 2, but 0 divided by anything is still 0. So our solution is 0, 2. If you were wondering, if I would have multiplied by -1 so that the y's would cancel, I would still get x to be 0. So you would still get the same thing regardless of what you choose to modify to make things work for you. So let's try one more of these where we have to multiply. So we have x minus 5 equals 5 and 3x plus y equals 31. So two ways of thinking of this. This is a 1x. So this is a positive 3. So I can multiply by -3 and they would cancel. Or I see a -5. I can multiply my second equation by +5 and they would cancel. All right. So it doesn't really matter here what I choose to multiply by, but let's go ahead and multiply on this by -3. So, so let's say we have -3, and we multiply not just this first number, but we have to multiply each number here. And our second equation stays the same. Okay, so we get, let's see, -3x. -3 times -5 is positive 15. -3 times 5 is -15. All right, and our second equation stays the same. So we find that our x's eliminate. -3, positive 3, they eliminate. 15 and 1 is 16. 31 and -15 is positive 16. That's nice. Divide by 16, we get y to be 1. We place this back into our original, so I'm going to use just our first one before we modified it. So we get x minus 5 times 1 equals 5. Okay, so x, that's 5 equals 5. We have to add 5 to both sides, being negative. And we get x to be 10. So our solution to this system is 10, 1. So one last example before we close this lesson. So elimination method is really nice, but only if both equations are in standard form. So that's one downside to it, is that it only works for a specific situation, which is nice because also this downside, if these aren't in standard form, most likely we can use graphing or substitution. So one last example to close this lesson. So going through this real quick, I can multiply by 3, positive 3 to get -6, or I can multiply by, oh, okay, so something that's, I just noticed something maybe you did too. If I multiply by 3, something's going to happen. Let's try this out. So if I multiply my second equation by positive 3, all right, so our first equation stays the same. And then we get positive 3x, -6y, and -15. So I did this to say I wanted to cancel the y's, positive 6, -6. But we see that we get -3, positive 3, and positive 15, -15. So everything cancels. What in the world does this mean? What does this mean? We have everything. What does this mean? We got 0 equals 0. What this means is that, so this conveys, this tells us that the two equations in our system are actually the same exact equation. So if I were to graph these two equations, they would be the same exact graph. So in terms of solutions, think about this. A solution to a system is where the two equations intersect, or the point that makes the two equations satisfied. But these are the same exact equation, so they're overlapping. So the number of solutions, there's an infinite. number of solutions. There's an infinite number of solutions. This is the situation when we get 0 equals 0, or some number equaling the same number. That tells us that we have an infinite number of solutions, that the two equations are the same. In the previous video, you saw that if we had some number equaling a different number, that tells us that there's no solution, that the two lines are parallel, that they're not intersecting. But here, we have infinite solutions. So that's it. That's the elimination method. So I wish you the best of luck in practicing this, and we'll see you in the next video.